Hello everyone and welcome back to Arctic Retro. Today I'm gonna take a look at this little computer from the 80s. This is a Laser 200 microcomputer. This machine was sent to me by a fellow retro computer enthusiast, and he wanted me to take a look at it because it isn't working. I usually don't do repairs for others because of the risk that I might damage something, and I don't want to do that. And I also don't work on stuff for money. So since I'm not a professional, I'm a hobbyist. But for this one I accepted because I have a nostalgic relationship with the Laser 200 because it was my first computer back in the beginning of the 80s. In fact, I have two boxed Laser 200s with a lot of equipment in my collection. Funny little machine. It was sold under different brands, but it was made by Video Technology or VTech, and that's a company that still makes toys or toy electronics. It was sold under the brand VZ200 and different other types of brands throughout the world. And there is actually a community out there on the internet. There are Facebook groups and things. So if you're interested in this machine, just Google a bit and you will find. Before I continue, I just want to say thank you to my good friends at PCB Way. These are some of the PCBs that they have made for me, and they make very good quality PCBs for very affordable prices. If you are a hobbyist and need some PCBs manufactured quickly, then just head over to PCBway.com and you will get an instant quote on the number of PCBs that you need for very affordable prices and very quick delivery times. PCBWay also provide other services like CNC machining, 3D printing, sheet metal fabrication and injection molding. They can also do your PCB assemblies, and they also provide advanced PCB capabilities. So thanks a lot to PCBWay for sponsoring this video, and if you want to learn more, then just go ahead and visit PCBway.com. I have made several videos about this machine before, so if you're interested, just take a look in my channel, search for Laser 200. Alright, so I'm just gonna hook it up now to my TV and check what is wrong with this machine. It also came with the 16K RAM expansion. Not sure what's going on in this, but something's loose there. This one is using a 9 volt DC input and it's center positive. Okay, turning on, let's see what's going on here. Oh, look at that. There is some graphics on the screen, so this machine produces an image. The machine has in fact the composite video output and RF. This is the composite video out, and yeah, as you can see, it's just garbage, and it's supposed to be a green screen with a basic prompt when you turn this on. Alright, so you need to find out what's wrong with this machine and start doing some fault findings here. I suspect there's something with the RAM, but you never know. I haven't really had a Laser 200 that didn't work, and I have never tried to repair one, but if we hook up the oscilloscope and try to measure around, I'm sure we can figure out something. Judging by the serial number, I would say that at least a couple of tens of thousands were sold of this. It's made in 1982, made in Hong Kong. Just gonna open it up. It has 6 screws. On the back side it has a DC 9 volt input. It has a tape port. It has a monitor connection, which is a composite video. It has an expansion port and some peripheral port there, which is blocked, and the TV modulator output. So let's see if we can open this. Then I think it's yeah, it has this keyboard that's soldered in, so that's a little bit difficult, but yeah, I guess we'll manage. It also has this massive shield here that's soldered onto some large grown wires here. We need to remove that in order to access the motherboard. Motherboard is under here. It's not very large. As I mentioned, this was my first computer. I got this from my parents. Yeah, I think it was in '83, and yeah, I learned BASIC on it, and it was quite fun. But then I moved over to the Commodore 64. So the machine is, well, it's kind of cheap. I guess they reduced a lot of cost by assembling it like this. I think maybe my solder iron tip is a little bit small for this. No, that worked. There's a few screws here on the board. Just gonna remove those. I think the board is now free to be removed. Yes. And it has a little of those piezo speakers attached to the case. So I guess I'll desolder those. Then that shield has 4 pins going through the motherboard. We need to desolder those as well. So I'm gonna use my desoldering station to remove most of the solder. Otherwise it's hard to get those out. That was some really nasty solder. It smells bad. Okay, let's see if we can remove this. Yeah, okay, it's out on that side. Okay, that revealed the motherboard. So this computer is a Z80 based machine. I don't know too much about these machines, but yeah, it has this little daughter board here. It's connected to the main board and has a little screw. Kind of annoying, it has 2 screws that goes through. Okay, so that revealed the rest of the board. So here we see the MC6847, that's a video display generator chip. This is the CPU, it's a D780C chip from NEC, and that's a fully Z80 compatible microprocessor. Over here we have a HM6116P static RAM chip. And here we have 2 ROMs, I think. Yeah, 2364C, that's ROM chips. Yeah, and there's one more static RAM chip, and these are 2K, so these are in fact the actual RAM on this machine. 2 times 2K, that's 4K, and that's what this machine had originally. Alright, since we see a picture on the screen, I guess the video chip is okay and the CPU is running, because otherwise it wouldn't produce anything. So it's time to pull out the oscilloscope and see what we can find on the data and address bus on this machine. Alright, gonna start by checking some voltages on the various chips, and I also printed out some of the data sheets or the pin layout on the most important chips. Start by checking the voltage on the CPU, and that's pin 11. Yeah, 4.99, that's really good. And there's the voltage regulator, the 7805, that takes the voltage down from 9 volts to 5. Then on the static RAM chips, yeah, 4.98 there, and yeah, same there, so those are good. And the video chip, it has VCC on pin 17. Yeah, 4.97. Then it's time to see what we can find with the oscilloscope with regards to the signals on the various chips. Alright, I hooked up the oscilloscope. I'm gonna check the CPU. It has a clock pin on pin 6. Yeah, that looks like a clock signal. But it is kind of slopey. I would expect it to be more square. Then we have the data lines. Seem to have some activity at least. Then we have D2. Does not look right at all. D0. Yeah, that looks a little bit better, but still it's just it's a strange kind of signal. I'm gonna try with the picoscope on the PC just to see maybe a little more clearer signals, and there's definitely something with the D6 pin on the CPU, and that's pin number 10, and if you check that, we see that's normal, that's normal, that's normal, and then on pin number 10 we have this, some kind of bad signal on that pin, never goes above 2 volts. The next pin is the 5 volt input, and that looks alright. Then we have the next pin 12, it's D2, and that also looks bad. D7 looks bad, D0 looks more normal. So why do we have that weak signal on some of the data lines? Maybe some of the logic chips are gone. Gonna check the schematics and see what the next step would be. Now I have checked the signals on more of the chips, the graphical chips, the SRAM chips, and they all show the same, that a couple of lines on the data bus is flickering low under 2 volts. So obviously something with the data bus, and the chip that's responsible for driving the data bus is this one. It's the 74LS245 chip. The 245 chip is an octal bus transceiver, and if we take a look at the datasheet for the Laser 200, it's the chip there, and well, it's not responsible for driving it, but at least it is driving the data bus. If we check the 74LS245 chip, we see that it has some inputs and some outputs and a direction pin. So everything that comes in should also go out, because it's a bus transceiver. It just transmits the signal from one side to the other side. So for example, on pin 7 we should have the same signal on A6 as we have on B6, that's pin 13. So let's for example check pin 6 and 14, those should be in and out, and here's pin 6, and yeah, there's nothing, there's a little bit of flickering, but no signal at all. And pin 14, yeah, and that looks like some sort of signal, but it is a little bit low. Let's try some of the other pins. Yeah, that looks more like it. Another pin on the input side, another pin on the input side, and that's the output side. That's one pin that's good. That's pin 3. Pin 4 is good. Pin 5 is good. But pin 6 is not good. And pin 7 is good. So in fact pin 2, 6, 8 and 9 on this 245 chip doesn't have a signal, and yeah, with that information I think I'm gonna replace this one. I actually have a new spare here. So then it's time to heat up the desoldering station and remove this chip carefully. Just gonna check that the chip is working, you never know. Yeah, chip okay. It could obviously be some other chip that is related to the data bus and that chip that's at fault, but at least I'm gonna pull out this one, and that way I can test it. That was a very easy chip to desolder, apparently. I think I got most of the solder at the first round. Yeah, the chip just fell out. That's how I like it. Okay, now I'm gonna test that chip, see if it actually was faulty. Unfortunately, it turned out that that chip is okay. So it was not that chip that is faulty, but still it is possible that the chip can be marginal. That is, it is faulty now, but still detected as okay in the chip tester. I am gonna solder in a socket and test the new chip. Quickly soldering in the socket. So that didn't fix the problem, but something changed. This is how it is now with the old chip, and let's try with a new chip. So that's with a new chip, and that's how it was first time I tried this machine. I don't know why it suddenly changed behavior. However, I'm now gonna measure on that chip with the oscilloscope and see if it's any different. Not really sure what's going on here with the new 245 chip. I get a clear signal on all the pins, including those that were bad before. So that's pin 6, and all the signals on the data bus are now very clear and fine. So I think maybe that 245 chip was a little bit bad, at least now after being in this machine and poured on for a while. But now with the new one we have the original problem, which is still the garbled graphics. So the next step now is, when the data bus is okay, is to check the RAM chips and see if they still got their correct signals. So I've checked a little bit around the other chips as well, and concentrated on the data bus. And yeah, here you can see, for example, some of the data lines on the ROM chips. This is the same picoscope that I always use, but yeah, it came with a new version of the software. It looks a lot better. But let's take a look at, for example, D1. So yeah, to me that looks like something is trying to pull the data bus lines down. There's some sort of bus conflict. Let's see, D0, yeah, same there. Something is fighting for the signals on the data bus. However, all the signals on the address bus is fine. So yeah, that's the address bus, looks totally normal. Since the data bus is shared among all the major chips, the ROMs, the RAM and the CPU and the GPU, then it's kind of hard to know who is causing the bus conflict. So in order to try and figure that out, I'm gonna desolder some more chips of the larger ones here and See if that releases the bus conflict. I'm gonna remove the two ROM chips first, and yeah, I don't know if there has been some repairs on this board. There's a lot of bodged wires, even this little here that seems to repair some broken trays. So with all these wires and stuff, it's a little bit hard to desolder these chips, but yeah, just need to be careful. That's one of the ROMs out, and yeah, it was quite easy to desolder chips on this board. Then I just hook up the board again and check with the oscilloscope, see if we have any changes. Yeah, in fact, there's some changes, alright. Now there's some different signals on the databus. So now that looks okay, and okay, so that's D0 and it looks kind of okay, and in fact on the screen now I can see characters. That's the clock, and then the next is D4. Yeah, that looks okay now. Well, there's some saw pattern, but it looks much more normal. So maybe it's the ROM. Maybe I found that right away. That was the chip that's in question here. I think so, but that's a chip that's not easy to replace. The pattern on the screen looks like that now, but after a couple of minutes it's turning into something else, like that. Now we can see actual characters from the ROM. Anyway, I'm gonna remove that ROM as well, just to take it out and check the signals after having that out. And then I can put both in a socket, and maybe we can replace those ROMs. We'll see about that. I removed that other ROM and I'm gonna solder in two sockets. However, still got that noise on the databus, like flickering just below 2 volts. Alright, since I saw some changes around removing the ROMs, I was thinking maybe some of the other control electronics regarding the ROM is faulty, and here's the schematics. That's the two ROM chips, and they are selected or enabled with this LS139 chip. That is a 2 to 4 line decoder. It gets a signal into pin 2 and 3, and then depending on that it will select either that ROM or that ROM, and half of that is used for selecting something in regards to the RAM, as it says here. So I was thinking maybe I'm gonna check that chip. So here's that chip, and it's 74LS139, and we're gonna check the inputs on pin 2 and 3 and see if we have signal on some of the outputs, and same with the 13, 14 in should have signal on pin 9 and 10 at least. Okay, so checking pin 2, which is the input. Yeah, looks normal. Pin 3, which is also input, yeah, looks normal too. Then the outputs 4 and 5 looks normal. 4. Pin 5 looks normal. Pin 6 and 7, I'm not sure if they are in use now, just high. This is the 139, and yeah, when thinking a bit more about it and looking at the schematics, I think this chip actually works as it should. It's because how this board is configured with 4K of RAM, 2K for the CPU and 2K for the video RAM, but I'm not entirely sure. Still, I have a suspicion that there is something wrong with the circuitry responsible for controlling the databus and the selection of the ROM chips and the RAM. So I pulled out these 3 logic chips here. I'm gonna test them now in the Chip Tester Pro. The first one is this, is LS174, that's a 6-bit the flip-flop, I think. Yeah, that passed, so that's a good chip. Then let's check the 139, which I thought was maybe bad. 124 decoder. Oh, will you look at that? That chip, it has failed. Sorry, the chip wasn't correctly in. It actually passed, so yeah, that's good. Then we have this one. It's a simple one. It's a 74LS32. That's just 4 simple OR gates. Yeah, that passed too. Just good chips on this. Oh well, that's how it is to find faults on these old machines when you don't have some sort of testing equipment. You just need to feel your way and try to eliminate things as you go. So none of these chips were bad. Okay, this machine decided to be tough. Yeah, I did a couple of more things which I didn't film. I desoldered both the SRAM chips and placed them in sockets, and then I tested those with the Chip Tester Pro, and they were both fine. Then I suddenly remembered, okay, I have the EEPROMs out. I can test them and try and read out the content. So the two ROMs are so-called 2364 mask ROM chips, and they are identical, only that the contents of the code on them are different. So if you try this one first, so you can't really find the 2364 chips here in the XG Pro software, but I selected this one 2732 DIP24, which this chip is, and then I just try to read it. Yeah, and it actually read in the content, and yeah, here we can see, in fact, there's basic commands down here. Now, it's impossible to verify that the content is the correct. You get a checksum, but I don't have the checksum. I actually Googled the serial number on the chip, but couldn't find any hits at all. Then with the other chip in the programmer, I do exactly the same. I try to read it. However, now it comes out with pin detect error, so I tried inserting it again and yeah, cleaning the pins and everything, but it cannot detect it as a valid chip. So my conclusion then is that that ROM is broken. Also, if I test the ROMs in the Chip Tester Pro, we can see this is the working or the one I think is the good ROM, and it calculates CRC. It ends with C7D. If we run it again, we get the same value, so it's consistent read. C7D. If I try the one I think is not working, test that one. It actually managed to calculate some CRC32 code, ends with 246, but if I run it again, I always get a different value, and that means that the ROM is not working. So you can see it calculated a different value now, so this chip is faulty. So how can we fix that? So we need a new ROM chip, and this is impossible to get hold of now, so we need something modern to replace it if I can't find a used one. So I was thinking about making an adapter to use a regular 27C128 EEPROM. This adapter converts from a 2364 chip to a 27 type, and the pinout is a little bit different, so there's a little bit of routing on this PCB, and this works for the Commodore 64, which also uses 2364 for its 3 ROMs, at least the oldest machines. So hopefully it will work on this machine too. Just need some pin headers here and solder in a couple of resistors there and a socket on top. I didn't have any 27C64 EEPROMs, but I'm going to use this one C128 which can hold two 8 kilobyte ROMs. In order to configure this adapter, I only need a 10K resistor on R1 and the other ones can be bridged. This is kind of small. Let's see if we can make this. R1 should have a 10K resistor, so I'm just preparing one of the pads there. The other one should be bridged together, so let's see if we can make a blob and connect between. Then we need a small 10K resistor. I have a little kit of surface mounted resistors. Doesn't necessarily have to be exactly 10K. It could be between 5 and 15, I guess. This is just to pull that line there high. I'm not very good at SMD soldering because it's so small. I have a hard time seeing the components, but this is quite large SMD, so should be alright. Then the other side. In fact, that resistor was a little too big, so yeah, I soldered it. It's a little bit crooked, but now it's connected. Let's check if there's 10K. Yeah, exactly 10 kilo ohms. Good. Okay, then it's time to solder in the pin headers, and I placed them in a socket just to have them straight to be sure that they fit. My only concern now is that this is gonna build quite high, so maybe we won't be able to fit it into the machine, but yeah. This adapter is now finished, and yeah, as you can see, it's quite high now. And there's even a socket on the motherboard. If you want to make such an adapter or order one, you can find it on Psychopera on GitHub, and you can also find this on PCBWay shared projects. And if you visit PCBWay shared projects, you can put these directly into your basket and order as many as you like for a reasonable price. So now I just need to burn the contents of this EEPROM. But first I actually need to find the ROM code, the binary files for the EEPROMs. I have the blank EEPROM into my burner. I found the ROMs on the VTech 200-300 Facebook group. In fact, there's a large files area there. So I guess I'll try, I need to use the 2.0 ROMs. It is marked with the chip number. However, on the PCB there is actually no labeling, so difficult to know which chip I'm gonna choose. But if they follow the numbering consistently, then it's chip 06 is bad. So I'm gonna assume that it's this image here, U09. However, if it doesn't work, then I'm gonna burn another one. And these are erasable EEPROMs, so I can just erase them and start over. Okay, so now I just load that binary into the burner software here, U9. Yeah, look at that. That in fact looks to be the correct ROM, because you see here it says Video Technology Basic V2. This text I did not see in the code for the good ROM, so I guess I selected the right one. Yeah, and it was verified and programming succeeded. Nice. I have inserted the ROM. Let's check and see if that works. Quite excited now. Nope. That did not work. Okay, so I'm gonna check a little bit more with this ROM and yeah, try a couple of more things, then I'll be back. All right, so it's been a while and I have tried different things. As you can see, I have two other adapters here. This one's the one I made. So I couldn't get the machine to work. I have burnt both the ROMs just to test that I didn't have a different version on the two ROMs, the one that's on the actual chip and yeah, the one I burnt, but no help. I didn't mention it, but obviously since this is a 27C128, you need to burn the ROM image twice to fill up both memory areas of the chip. Obviously I did that and I tried different things. However, the picture now looks quite different and it's more stable, looks more normal, except it's garbage characters. I guess I'll have to dig further in then. Alright, so this was a tough one. I tried to check some of the chips over here. I have checked all these three are working. This chip is some kind of vibrator chip. I don't have any means of testing that. However, now I desolder this chip. It's a 74LS86. That's XOR chips. So let's check it out. Well, look at that. That chip failed. However, when I test the chip in the EEPROM burner, the software has logic tests. It actually turns out to be good there, so that's kind of peculiar. So who do I trust? I think I'll solder in a socket there anyway and test with a new chip. Now that was a bummer. There's actually two different 7486 tests here. This one, it's called 7486 and it passed. However, I tested with this 7486L. That one failed, so not really sure of the difference. I also tested with a new chip and yeah, it behaves the same. Alright, so I have tested these three chips. They are alright. I tested this one, it's okay. And this one, the 393, that one is too okay. So now I pulled out this 74LS21, which is AND gates. And that one actually passed. So what have we learned so far? All the logic chips are alright. Seems like I have tested all the ones I could test except this one there, and the RAM is okay, and the ROM is might be some issues with one of the chips. However, inserting newly burnt ROMs with adapters did not help. So then we have the two major chips left to check out, and that's the CPU and the graphics chip. And yeah, I'm gonna desolder the graphics chip and replace it with a working one from another machine and see if that is in fact the case. So this is a working Laser 200. And this is how it's supposed to be when you turn it on. And I actually checked the signals now, and yeah, it seems like what I thought is some bus conflict and some strange signal is actually it looks to be normal, because I compared with this working machine and it has exactly the same type of signal on the data bus. Okay, let's pull out the graphics chip then. Time to remove that big graphics chip. Amazing how easy it was to desolder chips on this machine. Now in with the socket, and also on the other machine I have already removed the chip and soldered in a socket. So that I have something to compare with. Okay, now comes the question. This is the working machine, which is mine, and I have placed the graphics chip in a socket and it is working. Now I place the chip from the faulty machine into that and see if it works. I need to be careful with this modulator board here because it's connected with this very fiddly plastic type of ribbon cable, which actually broke off on the other machine, so I need to fix that later on that. Alright, we have ourselves a working video chip. So it was not that. Well, that's good because that's a chip that's hard to find if it's broken, so we know that's working then. So this is starting to become a little bit annoying, to say the least. I actually took out the CPU as well and replaced it with a working one, and yeah, as expected, it was not the CPU. So now that's taken care of, and I've secured this new wiring with some hot glue. So I actually took the time and desoldered the ROMs from my working machine and put them in a socket, and now let's see what happens if I replace those with the ROMs from the faulty machine. I had to use a little bit larger socket because I have run out of this size, but that is not an issue. I just removed the actual pins from the socket so that it's not possible to place the chips wrong. Alright, so now the first of the ROMs is in the good machine. Yeah, that ROM is working. Next one, the 06. So that was actually my first suspicion that this chip is bad. So let's see what it tells us on in this machine. Chip 06 testing. Oh yeah, look at that. That's a non-working chip. Alright, so that's the definitive answer. This chip is bad. Strangely enough, it makes a sound. I'm not really sure if you can hear it, but listen. The chip is ticking. I have never experienced that before. So if you have any explanation on to why the chip is ticking, or maybe it's some of the caps that starts ticking because some fault in this chip, I don't know. Alright, so now I have these two good ROMs. I can test them in the other machine. However, I think these sockets here, which has round holes, I think they are a little bit bad. I'm not really sure, but the chips feel very loose inside them, so maybe there's an issue with that as well. Okay, putting the good ROMs into the faulty machine, let's see what we get. Yeah, that's not good sockets. I mean, the chip is quite loose. That's cheap China sockets. No! Oh man, I'm not really sure what I'm gonna do next. This is very frustrating. Okay, I need to check for damaged traces or some bad solder points or anything like that, I think. Well, look at that. I found some suspicious solder point. I mean, this pin here, it seems like the pad is missing. I think maybe that happened when I desoldered the RAM. This is for no, this is for the ROM, one of the ROMs. And yeah, maybe that's it. Yeah, there's definitely something wrong. I mean, I already started to solder in a bodge wire before, but yeah, if I measure from that point over to that pin, there should be continuity. There isn't. And also from that pin over to that pin on the RAM should also be continuity. There isn't, so I need to connect that point and that point with that point. And that fault has been there all the time while I have troubleshooted all these things with this machine. Well, that's how it is sometimes. Okay, bodge wires are in place. Yeah, and nothing's shorted. Okay, so now the hopes are high again. Let's turn it on. Nah, no. I poked a little bit more around and actually tried to measure continuity in between yeah, the different traces on the ROM chips, and most of the pins are tied together because they are on the same data and address lines. For example, these two, these two, these two, these two, these two. But then suddenly on pin 6 on that row there is no continuity, and there should also be continuity with the RAM chip. So there's a break there somewhere. I checked with the other machine and there should definitely be continuity between those pins. And the 6th pin from the bottom here is that one, and my god, yeah, there's that bodge that was actually there from before. So that seems to be something that has been repaired on this board, a manufacturer issue or something. I did not put it there, and look at that, it's all loose. Okay, there's no contact there. Checked with my working machine and it's the same bodge wire there as well, so there's a missing trace between that point and there. That should obviously be there. Okay, let me just solder that little wire to that pin. Never ending story. Let's check now with the ROM chips in. This is it. Make it or break it. Nope. No, it didn't. Well, I just gonna have to keep hunting. Another try. What I did now, I cleaned up everything around the ROMs. I replaced the sockets with some other types of sockets and fixed up the bodge wires and I have measured everything now and I can't find anything wrong with the continuity between all the pins and where they're supposed to go. So let's check now. Yes, 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 yes. Okay, so, well, what can I say? So, really happy that this machine now works. That was a lot of work to figure out. Alright, so to recap, the issue is one of the ROMs is bad, which was my initial, one of my initial suspicions. However, when removing the ROMs and putting in some sockets and removing the RAM chip and placing it into a socket, I accidentally ripped one pad. I tried to fix that, it was not properly fixed and the sockets were bad, the ones I used. Not good sockets, so chips didn't make good contact. Also one of the factory bodge wires became loose eventually, so that was also a problem. Okay, at least now I have tested all the chips, they are working. Most of the chips are now in socket. Yeah, let's see if the keyboard now works. I have been bending this cable a lot, but hopefully it's not damaged. Yeah, seems to be working fine. So I asked a little bit around and I asked on the VTech Laser Facebook group if anyone has had these kinds of adapters working on these machines, and yes, definitely it's supposed to be working just fine like on the Commodore 64, and why wouldn't it? It's the same type of chip. So I think I misunderstood how the additional address lines supposed to be connected, and I now added a 10K resistor to all three, and yeah, and I burnt 2 copies of the same ROM image on this chip. I didn't put a socket under the chip to avoid it being too high in the machine, so let's check now if this works. So let's see now. Yeah, look at that, that actually worked. Nice. Okay, so now we have ourselves a working Laser 200 with a home burnt ROM. And I think this will fit under the RF shield that goes on top here. Okay, so now we have a working machine. Nice. The machine is fixed. So that was a lot of work for a simple faulty chip on this machine, and yeah, my investigations led to a lot of dead ends, but at least now I have checked that every chip is working, and I learned a lot about this machine for sure, and yeah, many of the chips are now in sockets, so it would be easier to repair this machine next time something fails. Alright, so what's remaining now? I'm going to take a look at that memory expansion, see if it works, and see if I can do any other types of restorations on this machine. But for now, I call it the day, and just want to say thanks for watching, and thanks for all the likes and subscribes. If you do subscribe, that actually means a lot to me, so hopefully you'll do that. Anyway, thanks again, and a special thanks to my patrons. See you, bye bye.